Number 2 on this review sheet, finding correlation and linear regression, means we're going to take this data and we're going to calculate a linear regression from stat and the calc menu items. Before we do that, we have to be able to input all of this data into the calculator, preferably usually under the list of L1 and L2. So let's take a look at that. In the calculator, hit second. Don't hit second. Just hit stat and then edit. And that will bring in your L1 and L2 lists, right? Make sure that up here is L1 and L2. If you input the list of data into L3, L4, or L5 or something like that, it's not the end of the world. You'll just have to tell the calculator where to find this data. The easiest thing to do, though, is to put it in L1 and L2 because the calculator will kind of have those labels in place by default. So I already input this data, right? L1 is going to be those X values on the top row. L2 here is going to be the bottom values on the bottom row, those Y values. So when you hit, let's say stat again, move over to calc and go down to number 4, linear regression. This is where you're going to tell your calculator where to look for this data. The X list is L1, the Y list is L2. And again, that's why it's the easiest thing is to put it in those L lists. But if you did not, or you can't for some reason, and you have it in the 4th or 5th, L5, L4 or something, then you can hit second and L4, number 4, and put it in there that way. I'm going to delete that now. You don't need to input anything else. Hit enter. And that brings you your values, right? R is your correlation coefficient, 0.9635, rounded to 4 decimal places. And this is a strong positive correlation, right? Describe the kind of relationship. This is a positive correlation because this is a positive number. This is a strong relationship because 0.7 up to 1 essentially indicates a strong relationship, right? So it's 2 parts. One is how close this number is to 1, and the other one is just a positive or negative number. Generally speaking, these are the values that you're looking for in this range for a strong positive correlation. If the number is still positive, but somewhere about 0.4 up to 0.7, that indicates a moderate relationship. And if those numbers are positive, then it's a moderate positive relationship. Anywhere from negative 0.4 up to positive 0.4, which is essentially close to 0. I can't spell. Close to 0. That indicates a weak relationship. And here it doesn't actually really matter whether it's positive or negative because the relationship is a weak one. Once you move down to the negative components, it's basically the same as the positive, just flipped. So from negative 0.7 all the way up to negative 0.4, that's a moderately negative relationship. And then it's stronger, but negative, when it goes from negative 1 up to negative 0.7. So that's what you should be looking out for when trying to determine what kind of relationship this R is describing. The other piece we're looking for from the same calculation are the values of A and B is equal to negative 205.73. And this indicates your line of regression. A is the coefficient of X and B is, in math terms, that's called the y-intercept or the constant value. So y hat is equal to 5.46 times X minus 205.73. These numbers are again coming straight from the calculator and placed into a y equals mx plus b linear equation. So we're going to use this linear equation, this regression equation, in order to predict the weight of a person that is 68 inches tall. And again, this is based on the data that's given to us. we can see that the heights we have, 62, 65, 66, 69, we don't actually have a data value that's where x is equal to 68. That's what the prediction is for. If it asked for, instead of 68, let's suppose it asked for predict the weight for someone that was, let's say, 45 inches tall, the minimum value for the x here is this, 54. So that means anything less than 54 is not a good predictor, right? It's not meaningful, is what the term is. Right? It's not a meaningful, this data doesn't give a meaningful prediction for anything where x is less than 54. And on the same side, 76 is the highest height here. So if someone is 80 inches tall, trying to predict their weight based on this data is not meaningful. But 68 is meaningful, so we can do it. So let's take this 55.46 times x, and we'll plug in 68 for x. And we'll work that out in our calculator, 5.46 times 68, and then minus 205.73 is going to equal a predicted weight of 165.55 pounds.